Thank you all for participating in our first WebEx tutorial for the ENLIGHT software. My name is Todd Haber. I'm VP of Engineering. With me is Dan Guthrie. Good morning, Dan.
Good morning, everyone.
Dan is a senior software developer, is really the architect of ENLIGHT, and he is the top resource to answer questions about the application, so we're pleased to have him here with us today. So Dan and I have prepared a tutorial today based upon a specific measurement example. We have come up with a measurement application. In our example, it will be a measurement of a bridge with several different types of sensors mounted on it. And so as part of this demonstration, we want to introduce you to some of the ENLIGHT tools and tips that would be used for creating the FVG and sensor elements and otherwise configuring the system. Additionally, we're going to establish some specific data storage goals and introduce the tools that ENLIGHT provides to realize those goals. And lastly, we are going to introduce the ENLIGHT Remote Command Interface, which is a programmatic interface that allows users to develop custom interface applications that subscribe to process data from the ENLIGHT application. So first, this is our fictitious bridge that we're going to be measuring today. You can see on the left the instrument that we've selected for this demonstration is an SM130, our dynamic swept wavelength interrogator. And connected to that interrogator, we have two separate fibers, each of which contain multiple sensors. On our first fiber, we have three different optical sensors. One is our OS3600. This is our long gauge temperature compensated strain sensor. We have an OS4100, which is a temperature compensation sensor, and we have a OS3100, which is a short form factor optical strain gauge, which we will compensate using temperature data from the OS4100. Now, all of these sensors are at a distance of 4,079 meters away from the SM130. With swept wavelength measurements, distance can have an effect on the perceived wavelength of each sensor, and so we're going to introduce the tools on how to contend with those real application distances between the interrogator and the sensors. Similarly, on fiber 2, we have two of our OS4300s, which are absolute temperature sensors, and those are a distance of 4,023. So for our example today, we literally have these sensors hooked up through spools of 4 kilometers and more. And so we're going to demonstrate how to contend with those distances. Okay, so that's our structure and our sensors. And we're going to establish early on some specific data generation targets. Basically, this is what the data that our customer wants to see, and how are we going to go about using ENLIGHT tools to realize that those data files. So first, we are going to log static strain data, or low-speed strain data, on our OS3600 and our OS3100 sensors. We're going to do that at a rate of 1 hertz. So despite the fact that our interrogator can collect it at 1,000 hertz, we're going to collect data on those sensors at 1 hertz for 1-minute blocks. In other words, 60 acquisitions at 1 hertz. And we're going to do that at a duty cycle of every 10 minutes, or a period of every 10 minutes. And we want that entire data saving program to last 1 week. At the end of each day, we're going to create a new file for those daily data saves. So that's going to be our data saving event 1. Event 2 is that we're going to log dynamic data on our OS3200 sensor. But we're only going to collect that 1 kilohertz data when the OS3200 sensor limits are reached. So we're going to go through a discussion of how to create limits and how to configure triggered acquisitions. As part of this data saving, we're going to include 10 seconds of pre- and post-trigger data. So that's 10 seconds of data before the 3200 reaches its limit and 10 seconds afterwards. Also, since we want to see the dynamic relationship between two of our sensors, we're going to include OS3100 data when the OS3200 is triggered. And so as part of that, we're going to create and save individual data files for each triggered event. So these are our two specific data generation targets, and later on in this tutorial, we're going to go through some of the tools on how to realize that. And lastly, at the end, we're going to introduce the remote command interface example, basically tell you what it is, how to use it, and then in real time create a simple but unique user interface using LabVIEW as a client of ENLIGHT. And so we'll show that with some of the basic building blocks for the LabVIEW remote command interface example, and then we'll show a higher level example that's included with the distribution of ENLIGHT.